6.6, we're going to solve even more problems related to slope of a line. This time, the particular application is we have two different points. So last time we were dealing with what if you're given slope. Well, this time we're not going to be given slope. We're going to look for the equation given two pieces of information, 2 points. So let's get right into it, and you'll see what I mean. In this case, in this particular case, we've got 2 points given to us, okay? And it says find the equation of the line. So let's just quickly first look over at strategy. 1, find the slope using the slope formula, okay? And then 2, sub the slope, which we'll have no, and one of the points, doesn't matter which point, okay, to find b. So the green here is me using the slope formula. So let's start with that. We're given our first point, we'll call that x1, y1, and x2, y2 can be b. So slope formula is here, substitute in the numbers, find that m equals 5. Okay? Then for finding the y-intercept, take either point. I chose this one because I like ones, they're easier to work with. So x equals 1, y equals 1, and I know my slope is 5 from over here. Okay? Then I just substitute into the y equals mx plus b. 1 y equals 5 is my m, x is my 1 plus b. Rearrange, solve for b. So here I just said this is 1 equals 5 plus b. Sort of inspection would tell you that b is -4, but going through the motions, subtract 5 from both sides, end up with -4 equals b. So there's my equation. Okay? And that's how you do it. And again, if I went too fast, just slow it down yourself, stop, re-listen to a bit, or pause to get all the information written down. Okay, this time we're going to use that strategy. We're going to use the strategy of 2 points. There's a lot of different ways you could do this. You know, you could do either. I'm going to choose 2 points just because that's what this lesson is about. But you could you know, use the graph to do rise and run, right? And identify, it's hard to identify in this one your y-intercept, but that'd be one way. Okay, so anyway, here we go. So I took 2 points that looked like they fell right on the grid. That's the first thing, is finding good points, right? So I just looked on the graph and find 2 that cross nicely. And those 2, I think, cross fairly nicely. It's sort of inherent when working with graphs, there's going to be some error. But anyway, so 3, 5, and 5, 6. So there's my points. Use my slope formula to find the slope. It's 1/2. Okay? Then I take, this is what we did in the last example. So I know my slope. Now over here I'm going to take that slope and my 1 point, substitute it into this equation. So now I have 5 equals 1/2 times 3. Well, 1/2 times 3 is 1.5. Put that in your calculator and you'll see. Plus b. Subtract 1.5 from each side. b is 3.5. So there's my equation. Okay? I suppose, you know, you could rewrite it a few different ways that would be accurate. You could rewrite it as y equals 0.5x plus 3.5. Another way you could write it, if you want it all fractions, equals 1 over 2x plus 7 over 2. 7 over 2 is 3/2. But whatever. Whichever way is fine with me. Shows, as long as you have a basic understanding of the strategy is what's important. Okay, so before we do this example, I need to tell you that I made an error when I wrote this question, and I've said 15, which gave awful numbers that couldn't work with. So I changed it to he slides, he's on a water slide park, which charges a fixed rate to enter the park plus a variable rate for each ride. So one day, he slides 14 times, okay, and pays $24. And a few days later, he slides 42 times and pays $38. So the question is, what is the equation that represents his fee? Okay? And we could, another way of asking, what would be the fixed rate, what would be the variable rate, that sort of thing. Because really, we're just given the results. So, but you just use the same strategy, okay? First, find the slope. So we have 2 points. Oh, which I never wrote. Oh, here they are. The 2 points are here. Okay? 14, 24, and 42, 38. So identify the 2 points, which is just looking at the information and saying, okay, he rides 14 times and pays $24. And you can see that the dependent's got to be the cost, right? It's got to be the money because it's dependent on how many times he rides. So this is independent, dependent. So write the independent first and the dependent. And then 42 times is $38. Okay? So use those 2 points, substitute in everything, and find M. Okay? Then just choose one of the 2 points. I chose the first one, as I usually do. Say y equals this, x equals this, and now we know our M is 1/2 or 0.5, either would be fine. And you substitute them in. So 24 equals 1/2 times 14 plus b. 1/2 times 14 is 7. So 24 minus equals 7 plus b. Solve for b, 17. And here's your equation. So that's the equation that represents it. So it doesn't ask you for fixed and variable rate, but I certainly could. And you'd say, well, that's got to be my fixed. He pays $17 no matter what. And my variable is 50 cents a ride. Okay? $1, it's half, right? But it's talking about dollars, so half of $1 is 50 cents. However you want to say it, doesn't matter. Yeah, oh yeah, 50 cents equals $1/2. Okay, moving on. Again, found an error. So this is our last example for this note. So it wasn't that it was an error, that it ended up with ugly numbers. So I changed it to make the numbers easier. So Ferd's walking towards a motion sensor. Remember we had those motion sensors out in class? Well, he's walking towards one at a constant speed. After 3.5 seconds, he's 6 meters from the sensor. That's telling us a point of data, right? Time is 3.5 and distance is 6. And then a little later on, at 5 seconds, he's 1.5 meters from the sensor. So his distance is shrinking, okay? Independent variable time always, and dependent is distance to sensor. So my 2 points then, you list your independent first, so 3.5 the first time, and that's when he's 6 meters away, and 5 is 1.5. Now something that we're going to see as we solve this, but I can see right away, he's moving towards the sensor. So once again, the distance is shrinking. It's going down. That means it's going to be a negative slope. I can picture it sort of looking like something like this, right? Because what you're measuring is the distance to the sensor. So he's starting some distance away. He's walking at a steady pace. At some point, he's going to run into the sensor, right? So I know the slope's going to end up negative. And let's just show that that's true. So first we find the slope. We take our 2 points, substitute in the numbers, and you end up with negative, right? Because you have 1.5 minus 6 up here, so you end up with a negative. Okay. In step 2, I need to find my b, my y-intercept, using the slope formula, or sorry, the y equals mx plus b formula. So I know my slope's -3, and I know my 1 point. So I just substitute in the point, substitute m equals -3, rearrange and solve for b. Okay, so that tells me, y equals -3x plus 16.5, or you could write it as, d and t for distance and time. That's it. So you have any questions about this note, or you need to take more time, please take it and list your questions so that, when I sit with you, we can talk about some things that maybe I went through quite quickly.